Continuing with chapter 10, we're doing now section 10.5, inequalities. We solve them essentially in the same way that we solve an equation or an equality. We can solve them graphically, just as we did with linear and quadratic equations. If it's a linear inequation, we just use the balance method, as we did for linear equations. And if we have a quadratic inequation, we can use the three other methods for solving a quadratic equation other than the graphical one, which we've already looked at. If you're going to use the algebraic method, be very wary. There is one slight difference to something you need to look out for when we're dealing with negatives, and I'll make a special point of that at the end of the second video. First one, I'm going to look at graphical solutions, and the second one, I'll be looking at actually doing it algebraically. Keyword you should know, the word integer. Integer means a whole number. It can be positive or it can be negative. When we're looking for a list of numbers that satisfy an equation, obviously you can have all sorts of decimals. There'd be an infinite number of decimals that would satisfy it, so you'll be invariably asked for an integer, a whole number. So it's not such a long list to write. There is another mathematical term, real number. That is a positive whole number, essentially the counting numbers. So I thought it's first of all important to look at the different signs we get and make sure we can actually read them. So this one here, 2x is greater than 12. 2x is greater than 12. That sign there is greater than. I always think the big end is with the bigger thing. So this is the big end, the big number. This is the little end, the little number. So 2x is greater than 12. This one, the sign is the opposite way around, so eventually we read that as less than. So 3x minus 2 is less than 19. Because you've got the little end there, it's less than the big end there, 19. Now, you can have them sandwiched. That's not a technical term, I just made that up really. Here we got them sandwiched, so 7 is less than or equal to. And that's what that extra line means there. Less than or equal to. 7 is less than or equal to 3x minus 2. But 3x minus 2 is less than 19. But again, you could read that the other way around and say that 19 is greater than 3x minus 2. We'll look at how we solve all of these later on. Got a picture here of how you'd go about solving some inequalities graphically. I've got two lines which each represent an inequality drawn. And I've got a straight line across here which is representing y equals 7. So y equals 7 is straight across there, all the points, y is equal to 7. A line going straight up, remember, will be x is equal to something. So this inequality is going to have a or equal to included in it. It could be a less than or equal to or a greater than or equal to. But the solid line tells you that the points on that line itself are included in the inequality. The dotted line is to when I've got the equal to not in there. So either it's less than that or it's greater than that. The points on this line are not included, and I do a dotted line to indicate that. Essentially, if it's a greater than, it's going to be above the line. If it's a less than, it's going to be below the line. And when you see those, you'll start working out which areas you're going to look at, because you're going to end up with some areas which are actually bounded by the inequalities that you draw. You see this area, this triangle here, will give you all the solutions that are bounded. So I would suggest it's less than y is equal to 7, but greater than that inequality and greater than that inequality. Okay, going to look at an example of a quadratic one drawn here. So very similar. Quadratic, we just get that U shape, it's a parabola, and we get a linear inequality drawn there, and quite often with these it's easier to see the area. You can guess this is the area where all the solutions are. So again, this one will be greater than the quadratic, above that, and less than this linear one. And then we've got this area bounded by those two lines. Okay, so generally, if the inequality is a less than, the solution is below the line. If it's a greater than, it's above the line. Both of these, you can see you haven't got an equal to included in the inequality because they're both dotted. This one, I just thought I'd take you through some of these skills you can use to actually interpret what inequality you've drawn. It's got a plural because there's a couple of parts to this question. We're only doing one, so we're only looking for one inequality represented by that line there. This, we go across 2 and up 4. So that tells me the gradient of the line is 4 across divided by 2, so the gradient is 2. That means in my inequality I'm going to have a 2x because the gradient is 2. Where's the intercept? The intercept there is at 4. So that means this inequality, this line is representing the inequality, and I would suggest it's less than, because that's the shaded area below it. So y is less than 2x plus 4. We'll look at more detail about how we draw these graphs and work these graphs out in chapter 14. But for now, number of x's is worked out by the gradient, 4 divided by 2, and the number, intercept there, you can just read off on the y-axis. So now we're on to a few actual graphs that we can draw to represent these inequalities. And the secret is we can't really draw a whole inequality. We have to just draw the equation. So we draw y equals x plus 5. In this one, we draw y equals 2x plus 1. Now, because this is a less than or equal to, we're going to end up drawing a line. Then the region is going to be below that because it's less than, and I've got a solid line because it's less than or equal to. This one, I'll draw the line that represents 2x plus 1, and it's greater than that, so it's above the line. So once I've got that 2x plus 1 line, it's above it because it's greater than, and it does need to be a dotted line because there's no equal to sign on there. If we get one like this, where I've got 3y, for me, the easiest way to do this is just to divide through by 3. So we end up with the equation y equals 3x minus 7 over 3. That will represent the same line as this one would. It's just easier to draw. If we get one like this, my suggestion again would be just swap it around, take the 2x over to this side, so it becomes minus 2x, and then divide through by 4. So we end up with y is greater than minus a half x, because that's 2 divided by 4, plus 7 divided by 4, because I've divided through by 4. So we draw the line that's equal to that, and because it's a y is greater than, it's going to be above the line. Greater than that, so above the line. That is going to be a dotted line, because there's not an or equal to. Okay, I'll now actually draw those for you, and that'll be done on the wonderful camera. But before, just talk about this example. This is one where it's going to be back like the previous slide. We'll end up drawing a quadratic for the y equals x squared minus 4. We'll get y is equal to 2, and again it's less than that, so it's going to be below the line, and then I've got another line which is going to be y is equal to x minus 1, so I've taken that over. So I've got a straight line which is y is equal to x minus 1, another straight line which is y is equal to 2, a quadratic that goes around like that, and I end up with this equation here, this area here, which is bounded by those 3 inequalities. Okay, let's get to the camera. You can see like my lovely manicured nails once more. The question gave me the inequality that y was less than or equal to x plus 5, so I just work out the points for the equation y equals x plus 5, and it gives me those there. You can then plot those points on a graph, and then when you've got that points there, you draw the line that joins them up. It's going to be a solid line because it was a less than or equal to. So there's a line, and that gives me the line with this area down here being all the points where y is less than or equal to x plus 5. So this is a point where y is less than that, so is this, so is this. So essentially we're looking at the y values here, so y is 4, 3, 2, 1, 0, minus 1, all the way down. Next one was the inequality that y is greater than 2x plus 1. So again we just work out the equation y equals 2x plus 1 and we'll plot these points. So I've got 0, 1, 1, 3, 2, 5, 3, 7, actually crosses that line there, and so on. The good thing about these is you only need to plot 2 or 3 points. You can do some easy points up here, because once you've got a straight line you can just continue it. So I've now drawn that line for y is greater than 2x plus 1 inequality. I've just drawn the line equal to, and obviously the greater than is going to be the area all above the graph there. If it was one that was actually being bounded by both of these, this would give me a nice area between these. All we'd need is another line that bounded this area here to give me a whole sort of triangle area that you sometimes get in equations, or sorry, in inequality problems. But essentially, remember, it's above, greater than, below, less than. Should this be a solid line for that one there? No, it should be a dotted line. But I can't rub it out, I'm afraid. I made that terrible mistake of doing it in pen. Oh dear. Whereas that one wasn't equal to, so that should be a solid line. This one should be dotted. Tut tut, Mr. Cotier. Have a go at those, drawing some lines, and enjoy the beauty of mathematics. Got one more video to do to finish off chapter 10. That's going to be solving inequations using an algebra method and also looking at number lines. So I'll see you for that, hopefully before the end of today.